Hi everyone. This video is going to show you how to make a sketch of the graph of a quadratic function when it's given to you in vertex form. For this example, I'm going to use the function f of x equals negative 1/6 quantity x minus 4 squared plus 3. And I notice that this is in vertex form because I can see the a, h, and k that I normally see in transformations of parent functions. Pause the video for a sec and list all of the transformations that you see. Hopefully you saw a vertical compression of 1/6, a reflection over the x-axis, and translations 4 units right and 3 units up. The 4 units right and 3 units up are especially important as they give us the coordinates of the vertex. I know that my vertex is going to be located at 4, 3. This also tells me that I'm going to have my axis of symmetry at x equals 4. The nice thing about having the axis of symmetry means that I'll only have to do the work to find 2 points, and then I can use the symmetry to find the third point. I plot my vertex at 4, 3, and then I need a couple other points. I can plug in any x value that I want for the other point, but since I have a fraction, I might want to kind of think a little bit more about what I might want to use. Again, any number will work, even if it's a fraction, as long as you put it in between the correct two integers and it's reasonably close. Your graph's still going to look okay and it'll be acceptable. But we can make our life easier with the fraction. Let's maybe think of something that's going to be nicely divisible by 6 since it's 1/6. So maybe x equals 10 would be a good choice. By picking x equals 10 and substituting it for x in the function, after I work everything out, I get negative 3 as my y value. So I can plot a point there at 10, negative 3. Now, because of the symmetry, I don't have to do any work to find the other point. If I know that 10 comma negative 3 is 6 units to the right of the axis of symmetry, then the other point on y equals negative 3 is going to be 6 units to the left of the axis of symmetry, which is going to have to be at x equals negative 2, which is 6 units to the left of 4. Now that I have my 3 points, all that's left to do is draw my parabola, and now I have a really good idea of what the graph looks like. So to recap, first use the translations to find the vertex, plot the vertex in axis of symmetry, and then input one more x value. Use the axis of symmetry to reflect that point to get your third point, and then just connect the 3 points to make the parabola.